So good day everyone. For today's discussion, we will discuss stirrup shear reinforcement. So I created a program in Excel which we can solve the maximum spacing, and also we can design the spacing for stirrups. So I will introduce what are the values to be inputted in this program. So for concrete, we have this the dead load, live load, and we also have the length of the beam, unit weight of the beam with beam depth or the total height of the beam, then area of beam, and area of beam can be calculated ito, then effective depth of the beam. So for stirrup naman, we have FC prime, FYT, diameter of steel, number of leg, area of shear calculated ito, then VU, depending if given yung VU, so input natin ito dito, and if hindi naman, so masasolve, makakalculate ka. So next, here we can see that we have for 2010-2015 NECP code. So this is to get the maximum spacing. So ayan. So ito dito lahat is calculated na value ito. Dito calculated ito lahat. So dito rin same lang 2001. This is for SMAX pa rin goal dito. So calculated pa rin ito mga values. So for review, yung difference ng 2010 at 2001 NECP code is that sa phi factor nila 0.85 for 2001, and for 2010 naman 0.75. So doon sila nagdi-differ. And dito rin sa pag-check ng kung adequate to carry shear. So for 2010, 0.67 square root of FC prime BW times D. And for 2001 naman, 0.66 square root of FC prime BW times D. Also, nagdi-differ din sila in terms of VC. So for 2010, that's 0.17 square root of FC prime BW times D. And for 2001 naman, that's 1/6 square root of FC prime BW times D. So dun lang sila nagdi-differ. Then, if, magdi-design naman tayo ng stirrup. So, dito tayo sa baba na portion. So, we can see here the theoretical table. So, X means refers to the varying distance of VU. And also, we can solve the VU with respect to its distance, VS, then spacing, and the number of stirrups needed. So, same lang din dito sa 2001. So, yun lang talaga yung difference nila, yung ano yung sinabi ko. Again, so let's now try to solve some problems. So, for problem 1, here, we have this problem. The beam shown in figure 4.5 has a width of 300 mm, overall depth of 600 mm, and an effective depth of 520 mm. The beam is simply supported over a span of 9 meters and carries superimposed dead load of 8 kN per meter and live load of 20 kN per meter. Unit weight of concrete is 24 kN per cubic meter. FC prime is equal to 21 megapascal. And Fy is equal to 345 megapascal. Determine the required stirrup spacing near the support using A2010 NECP and B2001 NECP. Use 10 mm vertical U stirrup with FYT 275 megapascal. So what we are going to do here is that we have to input those given. So dead load 8, then we have live load 20, and length 9. Unit weight 24, width 300 mm, H 600, and effective depth 520, FC prime 21, FYT 275. Check natin mamaya. 10 mm yung diameter. Then, di siya nagbigay ng number of leg. So, assume natin na 2. And wala ring video. So, calculated yung video dito. Check lang natin yung given. Okay. Ayan. So, ito yung mga calculated values niya. Ayan. So, dito, pag-check if section is adequate to shear stress, kailangan lang i-compare yung VS. Itong VS sa yung comparison value niya. So, 126 is 0.737 is less than for 78.971. So, that means okay siya. Adequate siya to carry shear. And if greater than naman, so we have to adjust the beam size. Ayan. So, required spacing ito, 177.236. And, as we can see, yung S-max natin is 177.236. Itong required spacing siya, no? So, equal siya sa required spacing. Why? Because, makita natin dito, Fs natin is greater than VC over 2. Ayan. But it is less than 2 VC. 243 is less than, is greater than, diba? 126. Ayan. So, if with that interval, dyan mabilong yung VS natin. So, that would mean yung maximum spacing natin is either D over 2, 600, or yung S, yung required spacing natin. So, the least value will be our maximum spacing. So, kaya 177.236 mm yung answer dyan. So, for 2001 naman, so same pa din. Ito yung mga nakalculate na value natin. Then, we have, by the way, R1 and R2 here are the reactions. R1 is for the left support of the beam and R2 for the right support. And para baka malito kasi. So, ganun pa rin. Check natin if adequate to carry shear. So, VS 120.814 is less than 471.822. So, okay siya. Max required spacing is 185.925. So, check natin yung interval ng VS. So, VS is greater than VC over 2 but less than 238.294. So, that means yung S-max natin is least nung required spacing D over 2 at 600. So, that would be 185.925. So, ayan. I hope that is clear. And let's move on for the next problem. Merong dito. Wait. Saan ba yan? Ito. Zoom natin. So, for the next example, design economical spacing of 10 mm diameter stirrup for beam which carries the factor loads shown. Use FC prime is equal to 21 megapascal and Fy is equal to 276 megapascal. So here, the difference in the first problem is that yung first problem, kinukuha natin yung maximum spacing. Dito, mag-design tayo ng economical spacing. So still, kailangan pa rin natin makuha yung required spacing at the maximum spacing. By the way, in designing stirrup, hindi na pagkuha ng maximum spacing, hindi nakasali yung S required. So, kasi doon na tayo nagko-compare. Ayan. So, di-design tayo. Sige. Input natin yung mga given. So, wala ito dito. Wala dito. Sa ito lang, W, meron tayong 80 dyan, 80, PU natin 150, 6 dito, 3 dito, Then 0 dito. Then yung beam width. Check muna natin yung beam width. 300, 600, 536. 600, 536. 536, 536. Yan. FC prime, 21 ba yan? 276 ito. 276 yan. Then, hindi pa rin nag-specify ng number of legs. So, 2 pa rin yata na siya. Okay na yan. Diyan. Yan. So, for 2010, 2015, so, yung VS natin is 237.557. And if we check natin yung kung section is adequate to carry shear, so, that is less than 493.708. So, okay siya. Ayan. Then, nakuha natin yung required spacing na 97.819. So, disregard lang natin itong S-max dito kasi for maximum spacing na problem yan. Pero, dito is design man yung ask ng problem. So, dito tayo. So, if design stirrup, by the way, if design stirrup siya, kailangan yung VU should be greater than VVC. So, makikita natin dito na yung VU natin is 272.12. That is greater than VVC natin na 93.952. So, magdi-design tayo ng stirrup. So, S required. So, kanina kuha natin yung S required, 97.819. Ayan. So, say 100. Ayan. Then, that is our S max. So, sabi ko kanina, diba? Hindi kasali yung S required. So, it's either D over 2 or 600. So, ito. D over 2 siya kasi mas maliit yung 268 sa 600. So, yan yung S max natin. So, if less than siya, S required is less than S max, so, stirrups are needed. But, if greater than naman yung S required natin sa maximum spacing natin, so, stirrups are no longer needed. Ayan. So, doon stop na tayo doon if greater yung S required natin. Then, yun na yung gagamitin natin na spacing for the rest of the beam, span of the beam. So, for first stirrup, we have as stated in the code. So, if beam yung dinidesign natin, so, first stirrup would be located 0.25 S. So, 0.25 ng S natin, that's 0.25 times 100, that's 25 mm. So, X natin dito, so first is doon sa critical section, which is doon effective depth natin, 0.536. 536, then say, second natin is 1.5. So, depende na ito, theoretical lang kasi ito eh. Ayan, so, ito yung mga respective VU and VS niya. Then, we have for spacing naman, ito siya. This is for required spacing with respect to the distance. Then, this is the maximum spacing. So, S-max ito. Constant lang ito, S-max. So, makikita natin dito, if less than siya, so, design, diba? If less than, design. If greater than yung S required, stop tayo doon. So, dito, stop it dito sa last part. Ayan. So, say, ilan ba ito? So, 97, that to be 100. Say 100 dito. Ito, 123, say 150 natin yan. 172, say 200 natin. Then, ito. Greater than naman ito. So, ito na yung ipapalo natin yung S-max. 268. So, say ito 50 lang. Ayan. So, we have here, 5.01, 526, 536, 536. Kaya pala iba yung wheel. Ayan. So, ayan. So, that would be 5.11 say 5 lang. 5.64 say 6. 3.33 say 4. 2.5 say 3. Ayan. Depende lang siya. By the way, ang concept here is that if maliit yung diameter niya, so mas marami yung stirrup na kailangan. Ayan. Ayan. So, And if maliit yung spacing niya, so mas okay siya, di ba? So, ganyan yung concept dito sa design stirrup. So, therefore, merge muna natin ito. So, therefore, use 10 mm diameter U stirrups for use stirrups 1 at 25, diba? So yung first stirrup natin 25 mm. Then so for 100 at 100 11, diba? 5 plus 6 at 100. Then 100 mm ito, sorry. Dapat may ulit ito. 100 mm. And 4 at 150 mm. And 3 at 200 mm. And tapos dito, diba? If greater than siya to 50 lang, so rest at 250 mm. So for the rest of the span, so 250 mm yung spacing na gagamitin natin. Ayan, so ganyan. That's for 2010. For 2001 naman, so ito yung S required natin, 117.762, so say 100 pa rin. And then less than man siya ng S-max, so stirrups are needed. So that would be from the critical section, effective depth natin 0.536, tama. So same lang yung ano natin, 1.5 pa rin dito. And ito, ayan. So ayan. So first, sa spacing natin, 117 say 100 ito. 151 say 150. 217 say ano ba, say 220 or yan, say 220. Then 268 say 250, 260. Sige, try natin 260. Yan. So 5.11 say 6. Try natin 6. Say 5. Depende lang ito sa inyo kasi. Or say 5 lang ito. No, hindi pala ito dito. Say 5 lang pala ito. So kung 5 yan, 10 lang ito. Sorry. So say ano dito, 6 na lang ito para meron difference dun sa. So dito say 4 pa rin. And dito say 2. Ayan. So therefore, conclusion natin yan. So copy ko lang ito. Control C. So therefore, use 10 mm diameter, use stirrup 1 at 25 mm, tama ba? For stirrup, tama. So 10, that's not 10, that's 11, diba? 111 yan, 6 plus 5. Then 4 at 150, so okay na ito. Then 3 at 200, tama ba? Hindi siya 2 lang ito. Hindi siya 200, 220 ito. Then rest at yan to, 260. So 260 yan dyan. So ganyan. So that would be the answer. That would be the detail in designing stirrup. So I hope you learned something in this program. So that would be all. Thank you everyone for listening.